This is a video on loops for C. Let's say after you graduate, your boss comes to you and asks you to write a program that would add the numbers 1 to 10, and you energetically respond, sure. So you write some code that looks like the following. You declare a variable total, and then you, using the assignment operator, which is the equal sign, you say that's equal to 1 plus 2 plus 3, blah, 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 all the way up to 10, and then you print the total. Now, yes, I know this is a simplistic example, but please bear with me. You no sooner finish it when your boss comes to you and says, hey, make it add the numbers 1 to 100. No, 1 to 1,000. So you start writing some code that looks like this. 1 plus 2, blah, 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 all the way up to 1,000. We print the total. So you go to your boss and you tell him you need a co-op. Just kidding. Seriously, if you started writing that code, you'd probably make a mistake and it would take a long time. That's a seriously long line. That's where loops come in. Loops let you execute a block of code, one or more commands, over and over. There are two kinds of loops in C, for loops and do loops. Let's start with for loops. The syntax for for loop is what's listed here. You begin with a for command, and then you have open parentheses, close parentheses. Now, then you have open curly brackets and close curly brackets. While it's looping, it will loop what is ever in the loop body however many times you want. So let's take a look at an actual example of that. Here we have our start condition. We have in index equals 1. That's where our variable is going to start. Then we have while in index is less than or equal to 100. Now, while the stop condition or conditions evaluate to true, it will continue to loop. And then at the bottom of every loop, after each iteration of the loop, it will do this step once. And we will, in this particular example, we will be adding 1 to the index. Let's try that out in Visual Studio. So I've got Visual Studio 2010 open here, and we've got the code. I just copied and pasted it in, and what it's going to do, it's going to print I love Star Trek 100 times. So let's go ahead and run that. Or not. Oh, there it goes. Hold on, it's a little slow. Let me drag that in, and as you can see, it printed Star Trek a whole lot of times. Now, while I've got you here, I'm going to do a little something about debugging. Some of you may or may not know how to use the debugger. The debugger lets you pause your program while it's running, and you can inspect the variables. Now, the way you pause it is what you do is you put what are called breakpoints. And the way you make a breakpoint is you click to toggle the breakpoint on and off that particular line. And what happens is it will run the code from top to bottom, and every time it hits the breakpoint or a breakpoint, it will stop. Now, let's go ahead and demonstrate that so we can run it, and you'll notice we've got no output, and we've got the little yellow line, and that indicates where the program has stopped. Now, with that little yellow line, I can hover over variables and I can see their value. So I can see that index is currently 0 because this line of code has not been executed. Now, if I want to execute that line of code, I can click on I have 3 buttons to choose from: step into, step over, and step out of. I usually step over. Step into and step out of won't make much sense until we get to procedures, but I'm going to go ahead and click step over, and we'll look at inspect index, and you can see that it's 1, and then it's going to print I love Star Trek. I'll bring up my output window, and you can see it printed 1. Now it hits the bottom of the loop, and then it goes back up, and it's going to test this condition, and it's going to say, is 1 less than 100? Well, it sure as heck is. But before it does that, it is going to do the increment. It is going to execute this code. So in index is going to go from 1 to 2, and we can see it's now 2, and that was less than 100, or less than or equal. So it's going to print I love Star Trek a second time. And if we want the program just to continue, we hit go, and it will run until the next breakpoint or the program terminates. And we can remove those breakpoints by clicking them and running. And so now it says press any key to continue. And that is a cool way of printing I love Star Trek 100 times. Now, the order in which the parts of a for loop are executed is, it does the start condition first, that's A. Then it does the expression for the stop condition. If that evaluates to true, then it does C, which is the body of the loop. It does everything in there. When it hits the end of the body of the loop, the closing curly bracket, it goes up and it does D. And so it will do whatever the step is. Now, it then goes back to B. So A gets executed only the first time through the loop. And it goes back to B, and it evaluates if that condition is true or not. And if it is, then it continues to loop. And it will continue to loop as long as B evaluates to true, and you'll get the cycle of BCD, BCD, BCD over and over and over. Your new favorite loop control variable is int index. Never use I, J, or K or anything like that. Why? Do I even have to say it? Readability. Alright, sometimes you may see examples like in this book, like this in the book. For I equals 1, I is less than 100, I plus plus do something. There's a lot going on there. First in part A, the start, they declare a variable and initialize it to 1. The B part, the stop, the loop control variable is I is compared to 100, and finally in part D, the step is incremented by 1. I recommend doing this instead. You declare the variable separately at the top. Then you have your standard conditions and spell it all out. Now, why do we do that? Because it's more readable. We declare all the variables at the top of the procedure. This is like the cast of characters in the front of a playbill for a show or an opera or something like that. We know all the characters and what their part is before any action takes place, before any code is written. On large projects, this is absolutely essential for success. Now, just so you're aware, it is possible to count down in a for loop by making the step negative. For example, here we have int index equals 100. The stop condition is while int index is greater than or equal to 1, and int index minus equals 1. That will count from 100 down to 1. Sometimes you need to do that. There are two types of do loops. There's the while and the do while. I pretty much refer to them both just by saying do loops. The syntax for a while loop is while, and then expression, and then you have your loop body. Now that's a pre-test loop. What that means is it evaluates the expression before it executes any of the code in the loop body, hence before. The syntax for a do while loop is do, then the loop body, followed by a while with your expression and a semicolon. Now that's post-test. The do while loop is guaranteed to execute the code in the loop body at least once because the loop condition is at the bottom. Now I'm going to ask you a question. Which is better? Do you want a while loop or a do while loop? Are you ready? Which is better? It depends. You always want to use the right tool for the job. If you're reading input from the user, you'll almost always want a do while loop because you want to prompt the user at least once to enter a value. For example, do printf, tell them what you want, and then read it in, and then do your check. That code will loop until a number greater than or greater to or equal to 0 is entered. Alright? So again, right tool for the job. For user input, almost always want a post-test loop. When to use a for loop and when to use a do while loop. You use a for loop when you know the number of times you want to loop. The technical term for that is you know the number of iterations. How do you know the number of iterations? You know the start, stop, and step. If you know those three pieces of information, you should use a for loop because it's the right tool for the job. Use a do loop when you don't know the number of iterations. If you don't know either the start, the stop, or the step, or some combination of those, then you need to use a do loop. Now use a do while loop if you want to loop at least once, and use just a while loop if you don't want to loop at least once. So again, recap. Use a for loop when you know the number of iterations. Use a do loop when you don't. Here is a valid example of a do loop. It's a post-test, meaning that the test for the loop is at the bottom. Print ask the user to enter a positive number, and you have your scanf statement for that. Now we don't know how many times we'll have to ask the user to enter a positive number before he gets it right. He may get it right the first time, or it may take him 20 times or 20,000. We don't know. That's why we don't know the number of iterations. So we don't know the start, the stop, or the step. Here is an invalid example of a do loop. We start off and we declare a variable. It's equal to value is equal to 0. We increment it by 1 each time through the loop. And then in the while loop expression, we have a condition that tests to see whether it's less than 10. So our start is 0, our step is plus 1, and our stop is 10. Since we know the start, stop, and step, we should not use a do loop for this problem. The right tool for a job is a for loop. If you use the wrong tool for the job on either a homework. If you do it on a homework, I will mark it wrong and hand it back to you, and you'll need to fix it. If you do it on a quiz, you'll lose some points, and if you do it on an exam, you'll lose more points. Now remember, the exams are made up of questions almost taken almost solely from the quizzes and homeworks. So if you do well on the homeworks and you study the quiz answers, you should do just fine on the tests. So back to our original problem where our boss asked us to add the numbers 1 to 1,000 and print the total. Without loops, our code would look something like this. In total, +1, +2, +3, and so on. However, even with a knowledge of loops, it doesn't seem to help us. That's the difference between knowledge and understanding. If you know what loops are, you've learned the part, but you don't know how to use them, you lack understanding, you aren't useful to a company. Let's rewrite our original problem. Instead of something like this, we're going to change it to something like this. Now I can assure you that the top line and these bottom lines do the same thing functionally. We can just add them up. We can see we're adding 1 plus 2 plus 3 plus 4. So instead of one long line, I have 1,000 very short lines. What we notice is that it is essentially the same line being repeated over and over. The only thing that changes is the number at the end. We can take it a step further and do something like this. We have index and total, and I've introduced a new variable, and I've assigned that to an initial value of 1. And then I said in total equals in total plus that index, so that replaces the old code. And then I have index incremented, so it goes from 1 to 2, and then I have the exact same pair of lines again, except this time the values inside are different. So I'll be adding 1 plus 2, and then 3 plus 3, and so on. And each time, for each pair of lines, I'm adding 1 to the index, which gives us functionally the exact same thing that we had in this code. So now all we have to do is copy and paste those two lines 1,000 times. Now that's not the most efficient way to do things, but it's certainly better than what we had. Now if we use the plus equal operator, we can shorten it up even more and make it easier to read. Now normally I wouldn't have these comments on the side, but they're showing you what the values are in there. So we use plus equal to take the place of int total equals int total plus int index, and int index equals index plus 1. Oh, pretty cool. Now that we have the same two lines repeating over and over, it's time to use a loop. Now what kind of loop do we want? Well, we know the start, which is 1, we know the stop, which is 1,000, and we know the step, which is increments of 1, so we want a for loop. So I set up my for loop. I have the initial start condition at 1, the stop condition at less than or equal to 1,000, and the step is plus equal to 1. And inside I have my int total plus equals int index. Now where did that second line go? That moved into my increment, or my index, or I'm sorry, my step. Wow, isn't that cool? We can add the numbers 1 to 1,000 with just a few lines of code. But wait, it gets even better. Our boss tells us the users keep complaining that our program only adds only the numbers 1 to 1,000. The user want to be able to pick the end number, so we do something like this. We create a variable called stop number. And then we prompt the user to enter whatever the numbers they want to stop at, and we read it in, and we use a do loop so that we make sure that it keeps looping while the number is less than 1. Then once they enter whatever number that is, we don't care whether it's 5, 10, 1,000, 20,000, we then do a loop from 1 up to that stop number, and notice I can use a variable instead of a hard-coded value inside my stop condition. Now by the way, I could do the same thing for my start and my index if I wanted to. And wow, that will print out the total. And it works for any number. And notice I say the total from 1 to whatever the user entered is, oops, can you see the bug in my code? Let me pause and fix that real quick. There. So it's printing out in total. I did that just to make sure you guys were paying attention. Haha. If I give you a problem where I tell you to add every third number from negative 10 to negative 24, you can't flip the start and stop around. So for example, I said negative 10 to 24, so the start would be negative 10 and the stop would be negative 20, but in this case it got flipped around, and so my start is negative 24 and my stop is negative 10, and I'm counting up. That's not following the instructions, and you'll get a different sequence of numbers and therefore a different total if you flip around. You'll get negative 24, negative 21, negative 18, negative 15, and negative 12. You should do the start at negative 10, like I said, to negative 24, and you would count down. That means you have to flip around the conditional operator, or I'm sorry, not the comparison operator. And so instead of less than, you would go to greater than, and that would give you the following sequence of numbers: negative 10, negative 13, negative 16, negative 19, and negative 22. And you can clearly see that that would give you a different number. So in the instructions, you got to follow them. Now, you may not think that's real important, but I read a story in Chuck Yeager's autobiography. Chuck Yeager is a famous, or was a famous, test pilot for the Air Force. In this particular story, he was telling how he had a friend that was a pilot, a test pilot along with him, and there was a new plane out, and his friend took the plane up and crashed, and he died. They had a second one, and they asked Chuck to take it up, and he took it up, and he got to a point where he was doing the maneuvers, and his stick got jammed, and I believe he was in a roll. So let's say he was rolling the plane to the left, and the stick would not go right, so he couldn't get out of the roll. So what he did is, instead of trying to roll to the right, he jammed the stick all the way to the left and flipped all the way around. So if you want to think of it as a clock, he was at the noon position, and his wings were at 9 and 3, and he rolled so that his wings were at 6 and 12. And then he tried to right himself, it wouldn't, and so he rolled all the way around counterclockwise and got his wings level again. Now, the only reason he was able to do that is because he had enough altitude, just barely. Well, they got the plane back on the ground, and they started searching for the problem, and it turned out that there was a bolt somewhere on the tail assembly that was, when it was, the instructions said to put it in from the bottom up. So you'd put the bolt in underneath, and the nut would go on the top. Well, there was an old-time mechanic who knew how to put bolts in correctly, and he knew that bolts always went in top down. Well, apparently when he did it this way, the bolt head snagged on something, and in just the right circumstances wouldn't allow the control surface to move correctly, and that's what killed a man. So when you're given specifications, you need to follow those. Now, if you believe there's a mistake and something really needs to change, then what you do is you go talk to the people who wrote the specifications, and you explain what you think the problem is and what the correct fix is, and bring it to their attention and let them know about it. All right? So that's how you handle those situations. It's important to follow the specifications. And so now you've learned all about for loops and do loops, and that is the end of this video.